Good morning students. So today this is our fifth lecture on a topic gravitation. As you know that today's topic of discussion is satellite. So what do you mean by a satellite? You know very well that between any two material particle there exists a gravitational force of attraction as per Newton's law of gravitation or universal law of gravitation. So when the two material objects, they might be heavenly bodies. We know very well that moon and earth, they are the heavenly bodies. Between moon and earth, moon is a lighter body as compared to that of what? Earth. So moon is revolving round the earth due to gravitational force of attraction, because the necessary centripetal force required for circular motion of moon round the earth, it is provided by gravitational force of attraction between them. So remember, this lighter body which is a moon and which is revolving in a circular orbit round the heavier body which is earth. So this lighter body, that is moon, is called the natural satellite of earth. So any lighter body which is revolving around the heavier body, that lighter body is called satellite of that heavier body. So moon is the natural satellite of earth. And remember, what is the time taken by moon to complete one revolution round the earth? See here, moon is revolving in a perfect circular orbit, and the time taken by moon to complete one revolution round the earth, it is 27.3 days. In 27.3 days, moon will complete one revolution round the earth. Now in addition to this natural satellite, that is moon, it is one of the natural satellite of earth. But we know very well that the different countries, they had launched their different artificial satellite. Man-made satellite or artificial satellites were launched, and these satellites, depending upon the purpose for which these artificial satellites were launched by the different countries, because they may be launched either for the purpose of what? Navigation purpose, or it may be for surveillance, it may be for communication purpose, looking into the space, or in order to monitor the weather. So these are some purposes for which artificial satellite may be launched. So depending upon the purpose for which artificial satellite is launched, their time period will be different. Now basically, as far as communication satellite is concerned, today we are living in the age of what? Communication. Without communication, you cannot survive in our day-to-day life. So as far as communication satellite is concerned, so what is communication satellite? Remember, any man-made satellite or any artificial satellite which is made by man, any man-made satellite or artificial satellite which is revolving in what? Revolving in a circular orbit in the equatorial plane of the earth. You know what is equatorial plane? So a man-made satellite or an artificial satellite which is revolving in the equatorial plane of earth in a direction same as that of direction of rotation of earth about its own axis, with a time period same as that of period of rotation of earth about its own axis, such a satellite is called a communication satellite. What is communication satellite? It is an artificial satellite, it is a man-made satellite which is revolving in what? Which is revolving in an equatorial plane of earth, equatorial plane of earth, in a direction same as that of direction of rotation of earth. We know that earth is rotating from west to east. So communication satellite will also rotate in the equatorial plane from what? West to east in a circular orbit around the earth with a time period. What is the period of revolution of that communication satellite? It is 24 hours, which is same as that of period of rotation of earth about its own axis. Period of rotation of earth about its own axis. Such a satellite for a person, see here, if here there is our country India, and Here is that communication satellite which is revolving in what? Equatorial plane. Now, because the period of revolution of that communication satellite is 24 hours and this earth will also take a time of 24 hours to complete one rotation. So, for the person who is just watching this satellite from this place, it seems to be what? Stationary, because both are rotating with same speed in same direction. So, remember, as communication satellite is rotating in a direction same as that of direction of rotation of earth about its own axis, so that's why communication satellite, it is called as geosynchronous. Synchronous means motion of earth and motion of satellite, they are pointing in what? Same direction, both are rotating in same direction. And second thing, because the period of rotation of earth and period of what? Revolution of communication satellite, it is same as that of 24 hours. So that's why that communication satellite, it appears to be stationary for the observer on the earth. Hence it is called as geostationary satellite. Hence it is called as what? Geostationary satellite. Now, as far as the purpose or the uses of communication satellite is concerned, it may be used basically for communication purpose. Communication of what? Communication of TV transmission, because every now and then we are having thousands of channels and TV programs, they were what? They were relayed. So, for the transmission of television signal, we can make use of a communication satellite, or for the transmission of radio wave signal, again we need a communication satellite. For the transmission of telephone signal, nowadays we are using mobile. So, the telephone signals, they will be transmitted with the help of a communication satellite. And as far as the examples of this communication satellite is concerned, the series of INSAT series of satellite launched by India, it is an example of what? A communication satellite. And the last but the most important type of satellite, it is known as a polar satellite. From the name itself, it is clear. Polar satellites, where they are revolving? Polar satellites, they are revolving in what? Lower polar orbit. See here, communication satellite, they are revolving in what? Equatorial plane. Polar satellite, they are revolving in what? Lower polar orbit. See here, this is north pole and this is south pole of earth. Earth is rotating about its own axis, and this orbit, the circular orbit which is passing over the north and south pole, is called polar orbit. And what I am saying, that the polar satellite, they are placed or they are revolving in lower polar orbit, means as far as communication satellite is concerned, if I measure the height of communication satellite, it is 3600 kilometer above the surface of earth. This circular orbit of communication satellite, it is 3600 kilometer above the surface of the earth, whereas as far as this polar satellite is concerned, they are revolving in lower polar orbit, means the height from the surface of earth, it is low, it is ranging between 500 kilometer to that of what? 800 kilometer, and that polar satellite is revolving in that polar orbit, lower polar orbit, at an altitude. Altitude means what? Height. Means the height of that circular orbit from the surface of earth, it is ranging between 500 to that of 800 kilometer. Remember, here this polar orbit is revolving in a lower polar orbit. In case of communication satellite, this communication satellite will take a time of 24 hours to complete one revolution. Here, because this polar orbit is revolving in a lower polar orbit, and therefore it will take a time of 85 minutes to complete one revolution between the north and that of south pole. Between north and south pole, means it will complete one revolution in the polar orbit in a time of 85 minutes, and during that period of time, earth will rotate from west to east. Some part of earth will be rotated. So remember that when polar orbit is, now how is that polar satellite is revolving? Polar satellite, it revolves in a polar orbit from north pole towards the south pole. What is the direction in which that polar satellite is revolving? Polar satellite, no doubt it revolves in lower polar orbit, and it also revolves in a direction from north pole towards the south pole. It takes a time of 85 minutes to complete one revolution. And remember, in a 24 hours, how many 85 minutes are there? In all 16 85 minutes are there. Means this polar satellite, it will complete 16 revolution in every day. In one day, how many revolutions were completed by a polar satellite? Polar satellite will complete 16 revolution in a day. And as far as this polar satellite is concerned, on that polar satellite, a camera is fixed. On the surface of polar satellite, a camera is fixed. And what is the purpose of that camera? That camera can view a small strip of earth in one of the orbit. What is the function of that camera? It will see or it will observe the small strip of earth. Say for example here, that camera may observe this small strip of earth in a time of 85 minutes. The camera which is fixed on a polar orbit, it can watch, it can view the small strip of earth in a time of 85 minutes. In the next 85 minutes, it can view the next strip. So the total surface area of earth, it is divided into 16 strips. It means in one complete day, that camera can have the view of entire surface of earth. So remember very well that as far as polar satellite is concerned, they can be used for weather forecasting, they can be used for meteorological purpose, they can be used for astronomical observation, and they can be used to study the solar radiation. So in examination there might be a question that explain the uses of polar orbit. So what are the uses of polar orbit? Weather forecasting, meteorological study, astronomical observation, or study of solar radiation. What is the period of solar orbit? Period of solar orbit is 85 minutes. How many revolutions that polar satellite can perform in one day? Polar satellite can perform 16 revolutions in one day. 16 revolutions in one day. What is the direction in which that polar satellite is revolving? Polar satellite revolves in a lower polar orbit. What is the height of that lower polar orbit from the surface of earth? Ranging from 500 to 800 kilometers, and it will always revolve from north pole towards to that of what? South pole, whereas earth is revolving from what? West to east. Earth is revolving from west to east. So this is all about what are the natural satellite of earth, what are the artificial satellite, what do you mean by a communication satellite, and that of a polar satellite. So whether it is CET exam or NEET or JEE exam, by chance there might be a question on this earth satellite or communication satellite or a polar satellite Let us now consider how to launch a satellite in a required or desired circular orbit round the earth, because we have to launch the satellite which can revolve around the earth, and those satellites, they may be launched for different purposes, maybe for communication purpose, maybe for weather forecasting, maybe for meteorological uses, maybe to observe the space. So as per requirement, we have to launch the satellite in a required circular orbit around the earth. Now for projection of satellite, the question will come that what is the requirement to launch the satellite? First requirement is that satellite must be raised to a certain height, desired height. For that purpose, it must be projected vertically upward with certain minimum velocity. Remember that VE is that minimum velocity with which a satellite is projected vertically upward so that it can escape from Earth's gravitational field. So the first requirement for projection of satellite, that satellite must be taken to a desired height. For that purpose, that satellite must be projected with what? Certain minimum velocity. The second requirement, that the rocket which is used to launch the satellite, it must be two-stage rocket. Now, what do you mean by two-stage rocket? Suppose instead of two-stage rocket, if we use a single-stage rocket, what happens here? Suppose here we are having a satellite launcher, and the fuel in the satellite launcher, the first stage of rocket is ignited. Means that fuel in the compartment of that rocket is ignited. So what happens? That rocket starts moving in upward direction, and it may attain a desired height. Whatever height you want to lift the rocket, you want to lift the satellite, it may reaches that desired height. Now here, the height attained by a rocket, it depends on, or there are two possibilities depending upon what is the velocity of projection. If the velocity of projection is less than the escape velocity, if the velocity of projection of satellite is less than the escape velocity, then rocket will attain a certain height and it will fall back on the surface of Earth. The second possibility, if the velocity with which rocket is projected vertically upward, if it is greater than the escape velocity, what happens? That rocket will escape from the Earth's gravitational field and it will move somewhere to infinity. Means, whenever we are using a single stage rocket, only two possibilities are there. Either depending upon what is the velocity of vertical projection. If velocity with which that rocket is projected vertically upward is less than escape velocity, it will attain certain height and that satellite will fall back on the surface of Earth. If the velocity of projection of rocket is more than that of escape velocity, then it will escape itself from Earth's gravitational field and it will move somewhere to infinity. Means in both the cases, we are unable to launch that satellite in a desired circular orbit. So let us see what happens. Instead of single stage of rocket, here we will use two stages of rocket. Two-stage rocket is used. So here is our planet Earth. From the planet Earth, the first stage of rocket is ignited. What happens? That rocket will attain a desired height. The amount of fuel in its compartment, it is so adjusted so that rocket can attain a desired height. On attaining a desired height, what happens? Here that launcher will rotate itself through 90 degree. Rocket launcher will rotate itself through 90 degree, and after rotating that mechanism through 90 degree with the help of remote, the first stage of rocket is detached and that second stage of rocket is what? Ignited. See here, from the Earth, when first stage of rocket, the fuel in the first stage of rocket is ignited, that rocket attains a desired height. With the help of launcher, that launcher is rotated through what? 90 degree. First stage of rocket is detached and this fuel in the second stage of rocket is automatically ignited, and it will provide the horizontal velocity of projection to a satellite. Means when that launcher is rotated through 90 degree, the fuel in the second stage is ignited, it means that rocket is given what? That satellite has given a horizontal velocity of projection. Means that satellite is projected horizontally at certain height above the surface of Earth. Remember, the minimum velocity or the exact horizontal velocity of projection, see here VH, it is what? It is the horizontal velocity of projection, the exact horizontal velocity of projection for which that satellite revolves in a circular orbit around the Earth is called its critical velocity, or sometimes it is also known as orbital velocity. Sometimes it is also known as what? Orbital velocity. So remember that the minimum velocity minimum horizontal velocity of projection for which satellite can revolve in a circular orbit round the earth is called the critical velocity. Now, depending upon what is the horizontal velocity of projection of satellite at a certain height above the earth, there are different possibilities. The very first possibility, see here, what is the first possibility? See here, curve number 1. When horizontal velocity of projection is less than that of critical velocity. What is critical velocity? It is the minimum velocity of horizontal projection at which satellite revolves in a circular orbit round the earth. And in case if that horizontal velocity itself is less than that of critical velocity, then that satellite will travel along. Look at this. This is a parabolic path. So whenever VH is less than VC, what is the path of satellite? Satellite travels along what? Satellite travels along ellipse. Satellite travels along an ellipse, and as far as this ellipse is concerned, look at this. Satellite travels along ellipse. See here, as far as this point of projection is concerned, that point of projection is lying at its apogee. Point of projection is lying at its what? Apogee means that point of projection is farthest from the earth. So what is the first case? Depending upon the horizontal velocity of projection of satellite, there are 5 cases. If horizontal velocity of projection of satellite at a certain height above the surface of earth, if it is less than the critical velocity, then satellite travels along what? An ellipse. With point of projection is lying at its what? Apogee, means it is farthest from the earth, and earth is lying at one of the foci of that ellipse. Remember here, when satellite is traveling along the elliptical path, satellite during its motion along an elliptical path, it may enter earth's gravitational field, and when it enters earth's gravitational field, what happens? It is acted upon by some non-conservative forces. What are the non-conservative forces? It may be air resistance. So due to action of non-conservative force like air resistance, it travels along a spiral path below that of earth. So this is all about the first case when VH is less than VC. Remember, path of satellite is elliptical. Now the second possibility, VH, that is horizontal velocity of projection of satellite at a certain height above the earth's surface, if it is equal to the critical velocity, then that satellite travels along a circular path. Satellite travels in a desired circular path surrounding to that of earth. Means the necessary centripetal force is provided by what? The horizontal. Necessary centripetal force is provided by the horizontal velocity of projection. The third means when VH is equal to VC, what is the path of satellite? Satellite travels along circular path. The third possibility, that when VH is less than VE, but VH is greater than VC. See, what is the first condition? VH is less than VC, satellite travels along elliptical path. When VH is equal to VC, satellite travels along circular path. When VH is greater than VC, but remember it is less than the escape velocity, means satellite has given a horizontal velocity of projection which is greater than its critical velocity, but it is less than escape velocity, means that satellite is not allowed to escape. It is forced to remain in what? A gravitational force. So when VC is less than VH is less than VE, once again that satellite travels along the elliptical path, with one difference here, that the point of projection P is at the perigee of earth, means it is closest to the earth. Position of point of projection is what? Closest to the earth. Point of projection P. It is what? It is at perigee. Whereas in the first case it is at what? Apogee. So when VH is less than VE, but VH is greater than VC, means VC is less than VH is less than VE. Path of satellite is once again ellipse with one difference, that point P is at its perigee. Means it is closest to that of Earth. It is closest to that of Earth. Now the fourth condition, that if VH is equal to VE, means horizontal velocity of projection of satellite is equal to the escape velocity. Then what happens to the satellite? Satellite will escape. It will not return back. Its velocity is 0 and it travels along a parabolic path. So whenever VH is equal to VE, means horizontal velocity of projection of satellite above certain height from the earth, then that satellite, it travels along parabola. That satellite will escape. The velocity of satellite is 0 and that satellite do not return back to the point of projection P. Satellite do not return back to what? Point of projection P. Now the last, or that is the fifth condition, that when VH, horizontal velocity of projection, is greater than the escape velocity, means that after rotating the launcher through 90 degree, after detaching the first stage of rocket, the fuel in the second stage of rocket is ignited and its amount is so high, so that satellite has given a horizontal velocity which is greater than that of what? It is its escape velocity. So naturally that satellite, it travels along a hyperbola. Path of satellite is hyperbola, and that satellite, as VH is greater than VE, so that satellite will escape into galaxy. That satellite doesn't return back to the point of projection. So this is all about, because in examination there might be a question that out of these 5 conditions you may be asked any 2 or 3 for 2 or 3 mark. Again there might be a question for 2 mark, why single stage rocket cannot be used to launch or cannot be used to project a satellite in a desired circular orbit. Now let us derive an expression for critical velocity. Critical velocity or critical speed, it is also known as orbital speed of a satellite. Let us consider that we are having a satellite of mass m, and let our planet Earth, mass of Earth is capital M. If I say that r is the radius of Earth and satellite is at a height h above the surface of Earth, the exact horizontal velocity of projection, the minimum or the exact horizontal velocity of projection given to the satellite at a height above the surface of Earth, so that satellite revolves in a circular orbit round the Earth, is called its critical velocity or critical speed or orbital velocity or orbital speed. So what is the function of this critical velocity? Because satellite is projected with horizontal velocity of projection equal to what? Its critical velocity, that satellite starts revolving in a circular orbit around the Earth. And we know for circular motion, what is essential? Any object can perform circular motion provided that object must be acted upon by what? Centripetal force. That object, it must be acted upon by what? A centripetal force. So, for circular motion of satellite round the Earth, certain centripetal force is required. What is that centripetal force required? Centripetal force is mvc square by r, where m represent mass of satellite, Vc, it is the speed with which that satellite is revolving, and small r, here small r represent what? R plus h. See here, small r represent radius of circular orbit. Here small r will be r plus that of what? H, because from this point to this point it will represent small r. So naturally this is equal to r plus h. So the necessary centripetal force required for circular motion of a satellite round the earth, it is provided by the gravitational force of attraction that exists between a satellite and earth. According to universal law of gravitation, what is the gravitational force of attraction between earth of mass m and a satellite of mass small m, and they are separated by a distance small r. So it must be equal to g into m divided by what? R square. So we are having two equations. First one will give us the necessary centripetal force required for circular motion of a satellite around the earth, and second one will give us the gravitational force of attraction between earth and that of what? A satellite. The necessary CPF required for circular motion of a satellite, it is provided by gravitational force of attraction between satellite and that of earth. Who is providing the necessary CPF? Gravitational force of attraction between earth and that of a satellite. So you can put the value of centripetal force mvc square by r is equal to gmm divided by what? R square. So 1 r on both sides get cancelled, mass of satellite get cancelled, and we have Vc equal to, look at this, Vc square is equal to gm divided by r. So Vc is equal to under root of gm divided by small r. Gm divided by small r. In the beginning of this topic, we had seen the relation that acceleration due to gravity, small g, is equal to what? Gm divided by r square if object is on the surface of earth. It means Gm is equal to gr square when object is on the surface of the earth. But here satellite is at a height h, that is at a distance r plus h from the center of the earth. So the acceleration due to gravity at an altitude h on the satellite is gh. So gh is what? It is the acceleration due to gravity acting on a satellite which is lying at an altitude, that is height h above the surface of earth. So gh is equal to gm divided by, now what is the distance between satellite and center of earth? It is r plus h. So gm divided by r plus h whole square. Therefore you can replace gm by gh into r plus h whole square. So the expression for critical speed Vc, you can write Vc is equal to, now you can replace gm by what? Gh into r plus h whole square. So Vc equal to under root of, see here, gm, replace gm by what? Gh into r plus h whole square divided by small r. What is small r? Small r is equal to r plus h. So small r is replaced by r plus h. So 1 r plus h get cancelled. So finally we had an expression for critical speed Vc equal to under root of, see here, under root of what? Either it is gm upon small r means r plus h, or you can express it in terms of acceleration due to gravity as under root of gh into r plus h. 1 r plus h, it get cancelled. Now this is what the final expression for critical speed of a satellite which is revolving around the earth at a height h above the surface of earth, and from this expression you can draw the conclusion that critical velocity, it does not depends on what is the mass of satellite, but critical velocity, it depends on mass of Earth. Look at this. Critical velocity, it depends on acceleration due to gravity at a altitude or at a height h. Critical velocity, it also depends on the height at which, or the height of satellite above the surface of Earth. And remember one thing, be careful that critical speed of satellite will goes on decreases when the height of a satellite from the surface of Earth goes on increases. So what is that important conclusion? Look at this. Critical velocity or critical speed of satellite, it is independent of mass of satellite, but it depends on mass of Earth, it depends on the height above the surface of Earth in which that satellite is revolving. And how they are related? That critical speed required for circular motion of satellite, it will goes on decreases as the height of that satellite above the surface of Earth goes on increases. Means whenever we have to revolve the satellite from a greater height, it needs a smaller critical velocity. A smaller critical velocity. Now here you can have a special case. Special case means what? Suppose that we can say satellite is revolving very close to the surface of Earth. Means when satellite is revolving very close to the surface of Earth, in other words, what you can say? In this case, you can say that r plus h is approximately equal to r, because h is very small as compared to that of radius of Earth. Remember, when satellite is revolving very close to the surface of Earth, means the height above the surface of Earth, h. Satellite is revolving in a circular orbit which is at a height h above the surface of Earth, and remember, as compared to radius of Earth, height above the surface of Earth is very small. Then in this case r plus h is approximately equal to r. Then what is the expression for critical velocity? Expression for critical velocity is Vc equal to under root of what? Gm divided by, now instead of r plus h you can write Gm divided by r. But we know that when object is lying close to the surface of Earth, Gm is equal to Gr square. So Vc equal to under root of Gr square divided by r, or it is equal to under root of G into r. So remember, as a special case, that whenever we have to find out what is the critical speed of satellite when it is revolving in a orbit close to the surface of Earth, then it is given by expression Vc equal to under root of Gm upon r, but Gm, it can be replaced by Gr square. Already we had replaced Gm because when satellite is at a height h, then the acceleration due to gravity acting on satellite is Gh, and we get Gm equal to Gh into r plus h whole square. But when satellite is revolving close to the surface of Earth, then r plus h is approximately equal to r. Therefore, Vc becomes equal to under root of Gm upon r into under root of Gr square upon r into under root of G into r. So this is about the basic expression for critical velocity. Now you can modify this expression. You can replace the mass of Earth. If I say rho is the density of Earth, then density equal to mass upon volume. Density equal to mass upon volume. Density of Earth equal to mass of Earth upon volume of Earth. Earth is spherical in shape, so its volume is mass upon 4 by 3 pi r cube, or mass of Earth simply is equal to 4 by 3 pi r cube into rho. Now you can put that value of 4 by 3 pi r cube into rho in this expression. So what Vc becomes equal to? Vc equal to under root of, see here, G, and that m is replaced by 4 by 3 pi r cube rho divided by, whole divided by what? R. So this 1 r get cancelled. So r square is left. 1 r it get cancelled. So r square is left. So this is equal to 2. See here, 4r square. When it is taken outside, it is 2r under root of. See here, what is left now? G pi rho by 3. G pi rho divided by 3. So you can also express the critical speed of satellite in terms of density and radius of Earth. So this is all about critical speed of a satellite.